sit down and stop that fascinating conversation you're having right now, because I have to talk to you about some stuff. And I won't take a long time to introduce things, but there's a few people, basically, I want to thank. Larry did a great job yesterday of thanking our sponsors, and that's really important. And I want to, can I point them out again? No, I have Phil's slide, but that's okay. Their sponsors are in the book. You know who they are, and thank you. But there's a couple of people who are very visible in some ways, but not heard from, and I want to acknowledge them. And one of them, of course, is Meredith. And so, Meredith, thank you so much. You are the heart and soul of this operation. It really works so well because of you, and at all levels, the people, the logistics, the thinking this through with you has been just such a pleasure, and I really enjoy our work together. And the other is Darren Grassman, and I don't know if you know that name as well as you should have, but you've been seeing her all through this meeting. She's the artist who does the paintings for the Gold Lab Symposium. And I didn't really understand until I got more involved in the nitty-gritty of the production of this in the last couple of years, how absolutely critical her vision and thoughts are to the organization and the core of what we do. And it's really striking to me how the artist in us and among us drive this symposium as much as the scientists do. And that collective vision, that unified approach to thought, not just in our work but in our lives, I think is what makes this meeting so special to me. And I was talking on the way over here about the kind of people that Larry attracts. And it's the sort of folks whose science is not only excellent, but who have that same kind of considered, thoughtful approach to their own lives, and are good at heart. And that's why I think when we talk in the hallways and in the meals and the like, it's so compelling. Because it's not just great scientists. This is a room full of great people. And it's such a pleasure to be part of this community and to help shape it. And I like to think that Larry knows everybody, and all of these people who I have met through him. But I see, especially in today's session, some of my own friends and colleagues and beloveds here today. And I'm really proud to be able to contribute my community to this community. So I'm really happy and touched. And I think I will stop there and hand this to Melissa, one of my dearest friends.
Thanks, Larry. I'm Melissa Hendel. It's really a pleasure to be here and to be the moderator for the session this morning. And I'm going to keep it really brief so that we can save time for our speakers. So it's my great pleasure to introduce Phil Fernbach. He's the professor of marketing at the Leeds Business School here in Boulder. He is the author of the book, Why We Never Think Alone. And he's going to talk today about revealing relationships between evidence and beliefs and the idea that we have overconfidence in knowledge. And I'm really excited about this talk because I think we all, especially lately with the misinformation that's spread, fundamentally there are a lot of overconfidence in knowledge. And so my question is not only how do we avoid that overconfidence, but does underconfidence exist in the world? And with that, off to our speaker.
Good morning, everybody. I'm very pleased to be here. I want to start by thanking Larry, but not for inviting me. I want to thank him for inviting my old friend and bluegrass guitar teacher from about a dozen years ago, so that we could have an impromptu jam session last night, which was super fun. And I guess this symposium is about bringing people from all different areas together and seeing what happens. So it's this great example, right? Like I got this email from Tony yesterday when I was at my computer, and it was just such a random occurrence and such a beautiful thing to happen. So thanks, Larry, for making that happen. I am a cognitive scientist, and I study the way that people think. I'm going to tell you about some of the work that I've been doing on this for the last dozen or so years. The starting point for a lot of my research and ideas is a phenomenon that was studied by a psychologist at Yale by the name of Frank Kyle in the 1990s. And what Kyle and his collaborators wanted to understand was, what do we know about kind of common everyday objects like zippers or ballpoint pens, things like that? What do we know about those things? What do we think we know about those things? And what's really fun about this research is that we can kind of do the experiment as we're sitting here listening to the talk. And so in this experiment, the first thing I'm going to do is I'm going to ask you to think about how well you understand something, a kind of common everyday object. My favorite example is the toilet. I love to talk about this. It's such a mundane thing. So I want you to think about how well you understand this thing, and I don't want you to think too hard about it. I want you to sort of give your impression, just your feeling of understanding. And if you're like most people, you're kind of nodding, and you're saying, oh, yeah, I kind of know how a toilet works. And you think that somewhere inside of your mind is something like this annotated plumbing diagram. Okay, but here's the trick. In the next part of the experiment, what I'm going to do is I'm going to ask you to explain to me exactly how it works in the gory details. Okay? And when I do that, something really interesting happens. This is what happens. Which is that we reach in inside, we attempt to explain, and we realize that we have just about nothing to say. Now, maybe you're a plumber or an expert, or you just took apart your toilet or something, and in that one instance, maybe you know something. But in general, we just do not know very much about the way that the world works. And yet, we have this initial impression that we feel like we understand things in quite a lot of depth. Kyle called that the illusion of explanatory depth. That's kind of the jargony term for it. I sometimes call it the illusion of understanding, or the knowledge illusion, which is the title of our book. Here's another really beautiful example. This comes from a paper, which I don't know if you can see this, but this has the best title of any academic paper I've ever seen. It's called Psychology with a C. This is work done by a psychologist named Rebecca Lawson. She wanted to understand people's understanding of bicycles. And she gave people a pretty easy task. So to avoid your own embarrassment here, I'm actually going to give you the correct solution here. So this is a schematic of what a bicycle looks like, okay? She gave people something that kind of looks like this, a drawing, but it was missing some of the parts. And she gave them the very easy task of saying, just draw in where those parts should be. Okay, it was missing the chain, it was missing part of the frame, and so on and so forth. Seems like it should be kind of easy. Well, it turns out that it's not easy at all. It's extremely difficult. These are some of the solutions of her participants. And the critical thing is here, these are not cherry-picked examples. This is kind of the average performance on a task like this. This is really, really hard, and I encourage you to go try to do this after the talk. It's not easy at all. So this is, to me, kind of a little mind-blowing, because this is an object that we interact with all the time. We have a lot of experience with it, and yet we just don't know anything about the way that it works, even where the parts go. This is something that was actually independently discovered by this Italian artist a couple years ago. He actually, I believe, did not know about Lawson's work, but at some point, him and his friends, big bicycle people, and he realized that none of them had any clue how a bicycle worked. And being a great artist, he decided to turn this into an art installation. So first, he had his friends try to draw the bikes, and then you get stuff that looks very similar to what Lawson found. But then, being an artist, he took it to the next level, and he actually built the bikes. And so, to me, an effective art installation is one that captures something deep and important about the human condition. And that's why I think this is an effective thing, because this is a really deep and important idea, I believe. And I'll get into why I think that's the case. Give you one kind of more cute example. There's a lot of biologists in the crowd. This is the citric acid, the Krebs cycle, citric acid cycle, which is one of the most important reactions in nature. This is something we all learn about in high school. I'm not sure why we learned about it in high school, because if you look at what people remember about this a little bit of time after the class, and every teacher in the audience is going to resonate to this, I think, you get stuff like this. People have no clue. We don't retain detailed information. So it's not just that we don't have detailed information about the world, but we can't retain it, especially if it's not important to us, if it's not something that we sort of utilize in our day-to-day lives. This person very helpfully drew a lemon because this is a citric acid cycle. So these are all kind of cute and funny examples. But I got interested in this phenomenon because I started to have the feeling that this is not about bicycles and toilets, but it's kind of about the most important stuff that we grapple with as individuals and as a society. There's this beautiful quote by Bertrand Russell, who's one of my all-time favorites, and he says, "The opinions that are held with passion are always those for which no good ground exists." And so I think of the kind of work that I'm doing is kind of following this idea. The world is really complicated. And the kind of stuff that we argue about, and we fight about, we stress about, is all really complex, and we don't understand it. As individuals, we have very little knowledge about the world, and yet we have really strong opinions about stuff. So I said, that's kind of an interesting puzzle. Why is that the case? So a lot of my work has been aimed at trying to understand the dynamics of the way that we as individuals store knowledge, the way that groups store knowledge and come to beliefs and opinions and attitudes about complex issues. And it's kind of opened up a lot of really interesting avenues that I'll talk about today. Just as one example of this, this is a study I did several years ago. And we were interested in whether this kind of toilet thing applies to important social policies. And these were the issues of the day at the time that we ran the study, and we brought people into the lab, and we essentially did the toilet experiment with them on these policies. And people come in, and they're pretty happy to give you pretty strong opinions about all these things. Everybody's got an opinion. And then we say, okay, explain to us how that works. And they grasp, and just like the toilet, they say, whoa, I don't really know very much about this. And then they become a little more humble. They say, oh, I don't understand that as well as I thought I did. And they become a little more open-minded. They back off their positions a little bit. It's not as strong of an effect as you would like, maybe, but we can talk about some of the reasons why that is. But this was, an early study that we ran that sort of told us, man, this stuff might be pretty important, okay? My focus today is going to be specifically on a bunch of new work that I've been doing on counter-consensus scientific attitudes. So things like, why are people against vaccination or genetically modified foods, things like that. But first, I want to just take a step back and explain to you or talk a little bit about some of the big concepts that I think explains why we experience the world in this way. Why is it that we know so little as individuals? Why is it that we overestimate how much we know? And then I'll get into showing you guys a bunch of data from some new studies. Okay, so I think the first observation to make is that it makes sense, actually, that as individuals, we don't retain huge amounts of detailed information about the world. And the reason for that is because the world is just massively complex. Tony and I were talking yesterday about a very simple melody in a well-known bluegrass song. And everybody plays it a different way. And the more you dive into it, the more you realize that this presumably simple thing actually contains multitudes of complexity. And everything is like that. The world is like that. We have hidden layers of complexity in everything. And so as individuals, if we wanted to accomplish anything, trying to master all the details of anything would be a futile exercise. And so that's really not what the mind is designed to do. There was a really fascinating study done by a psychologist named Tom Landauer in the 80s. Some of you might know the name. What he did in this study was he was trying to estimate what is the storage capacity of the human mind. And it was sort of the age of the dawn of computers. And what he wanted to do was let's try to estimate that on the same scale as we measure computer memories, okay? What he did was pretty clever. he actually meta-analyzed a bunch of memory studies. So in these studies, you bring people into the lab, they study information. It could be stories, pictures, music, whatever it is. You study it, and then you leave, you come back, and I test your retention, okay? Using that, what I can do is I can estimate a rate at which you learn and a rate at which you forget. And then I can just make some simplifying assumption. Let's assume people just learn and forget at that rate, and they live for 70 years and do that all the time, all of their waking hours. Just a simplifying assumption to get us to some kind of ballpark figure. And of course, this figure is not going to be exactly right, but think of it in your head about what you think that number is going to be. How many bytes do we have? And when I saw this number, I was just like, fell off my chair because it's 1 gigabyte. Which is kind of this, shocking. And of course, maybe this is not a perfect estimate, and maybe it doesn't capture all the kinds of knowledge that we have about the world, but this kind of explicit knowledge that we learn, it's very, very minuscule. The human mind is not a storage device. Actually, storage turns out to be pretty easy. We talk in the book about people with hyperthymesia, where they remember everything. Like they have perfect autobiographical memory recall. It actually is not a good thing for them. It causes a lot of problems. But that is not what the mind is made to do. So one of the big themes of the way I think about this is this idea of communities. The human mind is not built for individual thinking. It's not built for individual storage of information. Instead, what human beings really excel at is group complex goal pursuit. What we have is the capacity to form into groups where we have massive division of cognitive labor. Some people know some stuff, other people know other stuff, and we have evolved capacities for collaboration, cognitive collaboration, that allows us to pursue goals of arbitrary complexity. You think about the kind of stuff that we do today, like building spaceships or particle accelerators or apartment buildings, or science nowadays, right? Conducting a scientific experiment. You think about all of the people that are involved in that and how none of them could tell you everything about the project, right? In fact, maybe the most anyone knows is 1% or something like that. We have this massive distribution of cognition when we pursue these things. And yet, we're able to do it. This kind of changed my thinking a lot about the nature of the mind. And this is an imperfect analogy, but you can think about a beehive, where you have amazing complexity in a beehive. A lot of really complex problems are solved. Introduction to genetic diversity, protection of the hive, collecting food, all this different stuff. But it's not because there's anybody in charge. The complexity evolves because there's this division of labor. And you can think about human cognition in that way. And it kind of changes the way you think about the nature of thinking, I think, quite a bit. So that's I think is a really important idea that I never fully appreciated until I started doing this work. If you look at the field of cognitive science, it's all about individual thinking. This idea, it does exist in cognitive science, but it's not sort of the major focus. It's a lot more about what individuals do. Okay, so I think that this has very profound implications for the nature of belief and attitudes. Because what this means is that we are typically involved in a community of knowledge where no one individual knows enough about an issue to have a position or an attitude about it. This is true about almost anything you can think about. I'll talk very briefly about flat Earth at the end of my talk. And we all think we live in a round Earth, but most of us couldn't explain that, or why we believe that, right? We're just sort of appealing to the testimony of other people in our community. And kind of everything is like that. We are very used to drawing information in the world wherever it exists, not just from our own head. And so we do not have these strict boundaries between what's in our head and what's outside of our head. And that's what we think gives rise to this illusion of knowledge. By virtue of participating in a community, where the knowledge is spread out across the community, we take on a view, and then we start nodding along. And we say, oh, yeah, that's our view. And we get the feeling that we know and we understand because that information is out there. That's kind of our theory of where this stuff comes from. That's potentially the dark side of this. So there's this great, incredible benefit of communities that allows us to pursue arbitrarily complex goals and control our environments and do all kinds of amazing stuff. But it gives rise to this phenomenon where beliefs occur at the level of the group, and individuals end up maintaining strong beliefs about stuff that they don't understand very deeply. That's kind of the story of where these ideas come from. Okay, so that is all of the spiel about sort of the big ideas. Now what I want to do is I want to talk about this other puzzle, which is the tremendous gaps that exist between what experts say, and experts aren't always right, so we maybe can talk about that in the Q&A. But on average, experts are more right than people who don't know anything about stuff. There are tremendous gaps on a lot of different really important issues in terms of what the experts say and what lay people tend to say. The idea of scientific consensus is a little bit fraught, but we try to choose issues on which there's a relatively strong consensus, and I'll show you some of that. So the traditional way of thinking about these gaps is what's called the deficit model. This is a very intuitive idea. This is not a new idea. This was sort of acknowledged in the 70s and 80s that there was huge opposition to welfare-enhancing technologies. In the UK was a place where a lot of this research was done. That's where this science communication, public understanding of science literature really began. And the question was, okay, why? And they came up with this very intuitive idea, which is this deficit model. The deficit is the deficit in knowledge that lay people have about science. And the idea is if they don't know, then they're going to have opposition. And so really the idea is that we should try to educate people, try to improve science literacy, and all that kind of stuff, okay? It's a very intuitive idea. When I first read this, I said, yeah, of course, that makes perfect sense. Here's the problem. We're in 2023, right? 2023, right? And, look around. We're not solving this. Educational interventions just don't really work very well. We're not having a lot of success. So the public understanding of science literature, the science communication literature has kind of shifted and said, oh, maybe this deficit model is incorrect. I think that that's not exactly right. Let me give you another funny example. Here's a survey that was done. It's almost a joke survey, but it's real data at Oklahoma State. They asked people whether we should label foods that are produced with genetic engineering, and everyone says, yeah, we should definitely do that. And that's a really complex issue. And by the way, people don't know anything about GMOs. I've done a lot of work on this. People don't know even what genetic engineering is, what it means. But people have strong opinions about this. But if you ask them, should you have labels on food containing DNA, they agree with that too. So I see stuff like this and I'm like, yeah, like the deficit model, there's definitely got to be something right, something there. And in fact, if you look at surveys, you do find moderate correlations between people's knowledge and their attitudes. So lower knowledge does predict more counter-consensus attitudes. However, what I'm going to show you is that it's not just lack of knowledge, but it's this overestimation of knowledge. And the problem that creates for the deficit model is the people who most are in need of education are the ones who think they understand the best. And they're not going to listen to you. So that's a problem for the deficit model. You can't just educate people if they already think they understand these issues. I'll show you a bunch of data doing generally the same thing, which is looking at three things. The first one is how extreme are they in their counter-consensus views, like how opposed are you to genetically modified foods or vaccination or other kinds of things. How well do you actually understand? And we're going to measure that with these kind of true-false questions that are the standard approach in the science communication literature, the science literacy literature. They're not perfect, but they do index actual knowledge. So there's some correlation between people's answers to these questions and how much they actually know. And so it's going to be a noisy but a sufficient measure. And then subjective knowledge. How well do people think they understand these issues? Okay, so those are the three things. Just give you some examples. These are kind of some standard questions that would be asked. In all of these studies, we're going to look at general science literacy and also have issue-specific subscales, so questions specifically about genetics or about climate change or whatever it is that we're going to be asking about. And then you don't have to read this whole thing, but just to give you a sense of what subjective knowledge looks like, we say, like, how well do you understand this technology? And then we're going to give you some training about what different levels of knowledge would mean. In this case, I think, yeah, about a crossbow, because that's something that we pulled from earlier literature. But we do this a few different ways. It doesn't really matter how you measure this stuff. You always find pretty consistent things. Okay, I'm going to show you the first study that we did on GMOs, genetically modified foods. And here's the pattern of results, okay? So let me walk you through this real quick. So this is objective knowledge, and this is extremity of opposition to genetically modified foods. When I say opposition, it's always going to be opposition to the consensus. And this is about, there's a consensus about safety of genetically modified foods. There's probably many people in this audience who are much bigger experts on that than I am. So I'm not going to, if you want to talk about that, I'm going to defer to the expertise in the room. But here's the result, which is that as opposition goes up, objective knowledge goes down. That's pretty intuitive. That's like the deficit model idea. It makes a lot of sense. The more you learn, maybe you learn about the consensus, maybe you learn about why these things might be safe and so on. So you get this pattern. But over here, subjective knowledge, lo and behold, you find exactly the opposite pattern. So the people who are more opposed think they understand the technology the best. And in fact, this is the only paper I've ever read where the title of the paper tells you everything about the paper they need to know. The title of the paper was something like, extreme opponents of genetically modified foods know the least but think they know the most. Okay, so that's all you need to know. Because if you put these together, what you get is this pretty perverse result, which is that these guys over here, the extremists, they have this huge gap between what they know and what they think they know. That's knowledge overconfidence. Let me just show you a little bit of another twist on these results. This is a interaction chart showing the relationship between your objective and your subjective knowledge at different levels of extremity. And what you can see is that if you're a moderate, that is kind of in line with the consensus, you're pretty good at gauging how much you know. There's a fairly strong correlation. But that correlation completely goes away and almost looks like it might reverse a little bit among the extremists. That's, if you guys are familiar with Dunning-Kruger, this is kind of like a Dunning-Kruger effect. So the people who are the most extreme are just not good at evaluating their knowledge. And that makes sense, because if you don't know, you also don't know how much you know. Okay, I'm going to go through some of this kind of quick. This is another study just showing that same pattern in other countries. We did this with gene therapy. One of our reviewers asked, like, oh, is this true for gene therapy as well? Because in general, people are more accepting of gene therapy than of GMOs, but you find the exact same pattern for gene therapy. What we wanted to do next was look at a bunch of other issues. And so we looked at this set of issues. These are issues on which we could find a relative consensus in the literature, so climate change, genetically modified foods, nuclear power, vaccination, homeopathy, Big Bang, and evolution. Ran the same kind of a study, and here's the overall result. We find very strong evidence, again, for this kind of perverse relationship between knowledge and attitudes. So up here is objective knowledge. This is subjective knowledge. This is a different score. You can think of that as something akin to overconfidence. But these are on different scales, so it's not exactly so. But you can see that this different score, well, just the way that the directionality doesn't matter, but the people who are more extreme have a bigger gap. There are some differences by issue. It's a fairly robust pattern. However, we have found consistently that certain issues do not seem to demonstrate this. And interestingly, one of them is one of the most important, which is climate change. So actually, if you look over here, there's only 7 issues, so it's not really possible with the data that we have to say exactly what's going on here. And we don't, people's attitudes about these real world issues are multiply determined and complex and so on. So there's not sort of one thing going on. But one thing that we think might be going on is that the extent to which the issue is polarized, because these issues are very polarized, both religiously and politically, they might create kind of a boundary condition on the effect. Because if your group says, yes, it's definitely this way, or it's definitely the other way, then maybe there's not room for knowledge to kind of have an effect. But that's still sort of work in progress trying to understand that. So there is some nuance there. A pretty cool study we did was this idea of how much well do you understand it. It's kind of fuzzy, right? For the real scientists in the room, people doing hard science, you might say, oh, like what does that really mean? So what we did was we asked people to bet on whether they could answer the questions. So instead of saying, how well do you understand something? We say, are you willing to put your money where your mouth is that you can answer these questions? And that is, in economics, usually what they usually like to have is a nice, strong evidence that people really mean what they're saying. And the way this worked was, if they bet, and then they scored above average, they'd get a bonus. If they scored below average, they'd get nothing. If they didn't bet, they'd get some lower amount. So it's kind of, are you willing to take that risk? And this is such a beautiful result. I was really pleased with this. This is showing the percent who bet, and this is showing the percent who score above average and therefore get paid. And so this is almost a perfect demonstration of the overconfidence among the extreme people here, because they're much more willing to bet, but they're also less likely to score above average because they know less. And so they actually end up doing a lot worse in terms of their payout. We turned next to COVID. I remember I was in the gym or something, and I saw a news report about some data that Pew had put out about whether people were going to, everybody's stuck in their houses and everything, and I was just like, oh man, I can't wait for this vaccine to come out. And then you saw the data, and many people said, I'm not interested in that at all. And so I wanted to understand that a little bit better. This is a case where COVID was so new that you can't really claim a consensus on any of this kind of stuff. So the idea of a consensus is a little bit different. And I guess our understanding of the vaccine is still changing and evolving and everything. So I don't want to make a big deal about the consensus aspect of this, but the psychology ends up being precisely the same. So this was about COVID vaccine, and the attitude is about whether people would be willing to get the vaccine. This was actually before the vaccine was out. We did the same thing. Here are some of the items, knowledge items that we used. I'll let you have 10 seconds to look at those. And we find the same pattern. So people who are more opposed to the vaccine, they know less about COVID, but they think that they know more. We also collaborated with another research group who had a big study looking at all kinds of different COVID-related behaviors, like preventative behaviors and policy attitudes, but a huge array of these things, tons of knowledge items and everything. And they found exactly the same results, that the people who were most opposed to these measures were the lowest in knowledge and the highest in their subjective knowledge, had the highest levels of knowledge overconfidence. COVID is interesting because it actually became very polarized. It didn't start out so polarized, but then over the course of the pandemic became very, very polarized. So we also looked at this, doing things like controlling for political ideology and stuff. And it's not just about political ideology. The knowledge stuff also makes a difference. Okay, so I think I already said this, but I think the takeaway from all of this is that knowledge does matter. But I think that there's this huge stumbling block, which is that the people most in need of education are the ones who are least willing to listen. They feel like they understand the issues already. That creates a big challenge for discourse. Okay. So I'm going to do two more things. First, I'm going to talk about, very briefly, about sort of two directions of ongoing work that are a little bit different. And then I'm going to leave you with a few positive lessons about what I take away from this and like what we might do differently. So the first area where I'm starting to do research on is disruptive technology. And I wanted to mention this because I know a lot of people in the room are very interested in things like artificial intelligence and those kinds of issues. And I'm sort of a closet futurist myself. I'm a techno-optimist, and I kind of think that we're on the cusp of these tremendous changes in society that are going to happen really quickly, because we're on sort of the S-curve of adoption of these technologies. And the world's going to change dramatically in the next 10 or 20 years, in my opinion. It's really important to think about how are people going to react to those technologies. Because it's not enough to have a technology. People have to adopt that technology as well. So we've started to do some work on some of these kinds of disruptive innovations and trying to understand whether knowledge overconfidence plays a role in these kinds of things. So that's an area of ongoing research that I'm really interested in. Another area that I'm very interested in is conspiracy theories. I just wrote a paper about conspiracy theories, and one of the most meaningful experiences that I ever had as an academic was attending the Flat Earth International Conference. This is my former student, Nick. He's been involved in a lot of this work. We went to this conference. It was actually, the international conference was in Denver one year, and we said, I got to go to this. And it was one of the most incredible, fascinating things I've ever experienced. And the dynamics of knowledge that I've talked about throughout the talk, I believe, are sort of at the heart of why you can have conspiracy communities. It's like, how can entire groups of people come to believe something that's crazy? But that's what people do, right? That's what human beings do. Large groups of people believing stuff that's verifiably and obviously false. And the point of this is not to make fun of these people, although, I've done some of that. These people really well-meaning, energetic, joyful, interesting to talk to, and all this kind of stuff, and come to believe these like wild conspiracy theories. And I think if we can unlock this, it actually teaches us a lot about humanity. And this is an issue of really big and growing importance, I think, because with the way that the internet has allowed these communities to foster their beliefs, it's really sort of supercharged this conspiracy stuff. The flat earth one is really interesting. So I just very recently published a paper on this. So if anybody is interested, I can share that with you. Basically, there's theory in there about kind of where do these conspiracy theories come from, how does it work, and so on. And we focus a lot on this idea of the social network, because that's not an area that has been an area of attention for the most part. It's more about social psychology of what types of people are more into conspiracy theories and so on. And my take is the way these things happen is kind of very similar to the way that we come to our beliefs about any complex issue. And the community is really important, and so on and so forth. Okay, so I promised some positivity at the end, and I will leave you with 5 lessons that I take away. The first one is about intellectual humility. Intellectual humility is difficult because by our nature as human beings, the way we store knowledge in our communities, it's just natural for us to feel like we understand stuff we don't. That's just part of our brains. But it is something that we can learn. So you can teach yourself to habitually check your understanding. I've gotten better at that. I still make mistakes all the time. I mean, after you've heard this talk, I think maybe you'll find yourself going, oh wait, and realizing that this is just such a common occurrence. You can sort of habitually teach yourself. And this is to the question you were asking about underconfidence. Underconfidence isn't good either. And so I think of intellectual humility as being this calibration point. So it's not diffidence, and it's not overconfidence, but it's being calibrated. It's sort of having a strength of belief that is commensurate with how much you know. And that's usually a good thing, but I'll talk in a second about how that's not always a good thing. We actually need overconfidence. I think it's important. But a lot of the times, intellectual humility is good, especially if you're arguing with your relatives or something like that. Having a little bit of intellectual humility is good. And to that point, I actually think that this is a really good tip. If you want to improve your discourse, you have to get out of an advocacy mindset. So I didn't mention this before, but in that study where we asked people to explain policies, we had another condition. It was very similar. And instead of explain how it works, it was tell me why you believe what you do. Give me reasons for your position. You don't get these benefits if they elaborate on their reasons for their position. And so when we argue about stuff, we tend to be in an advocacy mindset, like here's why I'm right and here's why you should believe what I believe. But the thing is, none of us ever know what we're talking about typically. And so that's kind of silly. Like what we should be doing is working together to try to understand the issue in more depth. Usually when we're arguing about social policies, it's all about costs and benefits and nuance. It's not about like you're right and I'm wrong. That's a very rare that an issue is that black or white. And so I think this idea of being in an explanatory mindset is really helpful for actually opening people up, making people a little more open-minded and not as defensive. If you do it in the wrong way, it can come off as defensive. Oh yeah, explain that to me. How does that work? And then people get defensive because they feel like they're being made fun of or they're embarrassed or whatever it is. But if you can actually earnestly come together and say, let's try to understand this issue together, I think often it'll kind of open minds. You might find areas of disagreement, but you might just find that, oh, actually, we kind of agree on this stuff. I think a lot of our arguments in this country are of that nature. You know, we argue about healthcare and we demagogue the issue and we say like one side wants to kill babies and the other side wants to do whatever. But you know, 99% of people kind of want the same thing out of a healthcare system. So I think that this is a pretty good tip. All right, lesson number 3, our views are not our own. This is something that we often forget. When we take a position on any complex issue, we're really just parroting what our community is saying. Like it's very rare that we do enough research that we actually understand the issue in depth. And so it's very easy to fall victim to this idea of feeling like we understand the issue better than we do. It's hard to know when you're in an echo chamber. It's like being in a house of mirrors because it feels right. You know, you're around people you trust and everything. So it can be really hard to avoid that. So what can you do? Like listen to opposing viewpoints, seriously listen to them, and try to understand what the best argument is on the other side. Make sure that the people that you're listening to have true expertise, not just, you know, feigned expertise or that they're overconfident and so on. Okay, lesson number 4. I like this one a lot because I've always been the person to ask a lot of stupid questions. We should be asking a lot more stupid questions. The world is dramatically complex, but because everybody has this individualistic perspective about cognition, we think that the key to intelligence is being like really smart, knowing everything, and all that. Like really what we should be thinking about, because human beings are built for groups, built for pursuing complex projects together, it's like, how well do you contribute to a group? That's more important. People feel like they should know everything because we all have this model of the mind as being this individual thing. We should all be experts on everything. We should know everything. So people are embarrassed to ask. And so, you know, I'm often in settings where nobody asks the obvious question. Everybody's nodding and going, oh, yeah, but nobody knows what the heck's going on. So have the courage to ask those stupid questions. I think it'll be enlightening. And then the last one is to your point. I don't think we could have a vibrant society if people didn't have some measure of overconfidence. No one would ever start a business if they were calibrated about their chances of success, right? There's a lot of things that we would never try and never do if we thought about all the things that could go wrong or all the complexity involved and so on. This is a hard balance to strike, right? You have to take chances. You have to sometimes say, okay, I'm not going to think about all of the things that could go wrong. I'm just going to go for it. And then you learn from your mistakes. But there are other situations where I think intellectual humility is really called for. So there's no easy answers here, but that's it for me. Thank you.
That was just an incredible talk, and I think we're all going to go home with a little bit more skepticism about our particulars and how we approach the world. And I know we're going to do, there's lots of hands up, so I see one right here.
Thank you so much, Phil. I really loved your talk. I just started as a professor at Mines, and I just want to talk to you like afterwards sometime
cool.
because I think this is really interesting. I was in info here as a postdoc though, so. But my research looks at online communities and actually the relation of spirituality and religion in people's use of online communities, especially for healing. And so I was interested, so you kind of positioned at the beginning of the talk a little bit about having healing thoughts and that relation. And I'd love to have you kind of wrap up and kind of come back to that. And just a couple comments on, so you were talking about this cognition issue being spread across people at the beginning. Have you ever heard of the theory of distributed cognition?
Sure, yeah.
Yeah, so it's this idea that we take our cognition and we invest it not just in other people, like what you were talking about, but also in the machines and the technology that we use, that we offload memory into that type of a system. And that obviously kind of happens in online communities as well. And you touched on this a lot, but I think some of the groupthink things that you're talking about are really deeply intertwined with that. So I'm curious about how you think about healing thoughts and that relationship to some of these online spaces that people are...
I need you to elaborate a little bit more on what healing thouts are. Healing thoughts? What does that mean?
At the beginning, you were kind of saying, like, did I mishear that? I thought you mentioned something about how, kind of the way that you think about things, and that being something that can contribute to, I mean, I think the word healing thoughts was something that you said. I could be misremembering.
I might have said it in a trance or something, but...
Okay. Hearing thought? Okay. Well, anyways,
Sorry.
maybe even if you didn't say that, what do you think the relation is between kind of health and people's use of these types of platforms?
Yeah, that's really interesting set of questions that you brought up. So definitely, we are social creatures, and the meaningfulness of our social connection is one of the most important contributors to our psychological and emotional health, absolutely. And I think that's a huge reason why people get involved in communities that are aligned around certain ideas. Like that's, religious communities, that's a huge thing. Conspiracy communities, that's a huge thing as well. And there are tremendous benefits associated with that, no doubt about it. So in the flat earth community, a lot of people are deriving a lot of their meaning in life. They're generating friendships. They got something to do on the weekend. There's all these tremendous benefits. Now, what's interesting is that, I don't know if you ever heard this idea called Pascal's wager, but you can't just believe something because it provides some kind of functional benefit. There has to be something in your mind that actually gets you over the hump of actually believing it. So I actually don't think most of these people in the flat earth community or religious community just do it because they want to have friends there and stuff. But it's all wrapped up together. So yeah, there are potentially huge benefits, but at the cost of potentially having really incorrect beliefs about the world. So yeah, that's kind of a trade-off, I guess, yeah.
Phil, really enjoyed the presentation. You may have hinted at it, but can you expand on what you view as the evolutionary benefits of people to act based on belief in the absence of objective knowledge? My take is it allows conditioning, it allows societies to move with dangers, disadvantages and advantages. But I think it's intrinsic to what has happened in evolution for crowds to be able to move, because you can never all get all the data.
Yeah, absolutely. I think it's part and parcel of the way that we solve problems as groups. You can't, as an individual, have enough knowledge to actually support it, but the group has to take some action. So I actually think it's this sort of necessary condition that was selected for evolutionarily. I mean, I'm not an evolutionary expert. We do have some chapters in the book on evolutionary psychology, and there is really interesting research looking at the like group selection and those kinds of issues, where there's this idea called the social brain hypothesis, where the idea is really that the mind evolved to actually be able to maintain these social groups so that the group could then distribute labor and engage in more and more complex kind of behaviors. So yeah, absolutely, there is an evolutionary story there. Yeah.
That was a really good question, and I just wanted to add one comment. Yesterday, we were hearing about the need for the little aphids to be stochastic in their jump response, right?
Okay, I missed that talk.
Oh, that's too bad. So I'm just wondering if, like you mentioned, that there's, like we have to sometimes take chances, right? We have to sometimes believe even in the absence of evidence, or else people wouldn't start businesses, right? So I'm wondering if there's an evolutionary advantage to ignoring or not knowing things, because then we have these advantages that might come of that. Anyway, I'm just.
I think that's also the solution to how a soccer goalie should behave in a penalty shootout. They have to be completely stochastic. I don't know if that's what the aphids thing was, but that.
Thanks, Phil. I too thought that was great. So embracing an idea means belonging to a community of people who have similar ideas. Is there any data about critical mass of people within a community that's required for an idea to take hold?
Gosh, that's such an interesting idea. I don't know offhand. That would be work that would be done in network analysis or sociology, which are a little bit outside of my area of expertise. And so I don't know about specific papers saying like what is the number that you need for a critical mass. But that's a super interesting question. And there's lots of amazing work going on. With the advent of social media data, there's an ability to mine that to answer questions like that that are super interesting. So there's a lot of work going on. It's a very robust area of research. But I don't know offhand the answer to your question.
I have a question about some of your graphs. How do you measure extremity and opposition? Is that self-declared, or is that something that you determine? And if it's self-declared, that also imposes a lot of bias into how you perceive yourself.
It is self-declared, so we just ask people, how do you feel about this issue? I'm not sure what you mean by bias and how you perceive yourself.
Well, you might perceive yourself as not extreme at all, and I might perceive you to be as very extreme, and where the truth is very subjective.
I see. So you're saying that people might use the scale differently. Yeah, I mean, in research, in behavioral research where we collect judgments like that, there is always an assumption that people might use the scale differently. But if they're not, that's not going to be systematically biased in one direction or the other. That's kind of the assumption of, our guiding assumption when we do that kind of work. So that kind of noise is just going to be noise that's canceled out over the larger your sample size and stuff like that. So while it's true that people might use the scale differently, and they certainly do, the judgments of how do you feel about this issue, I think on average, are reliable in terms of tracking people's attitudes.
Thanks, Phil. Maybe this is in alignment with lesson number 4 with stupid questions.
Yeah,
but
good.
It seems like alienation, like cultural or social alienation, is playing some role in these different groups, and maybe alienating from one group, coalescing into another, grabbing the thoughts of that group. I was just wondering if you could speak to that at all.
That's something that's talked about a lot in the conspiracy literature. So that's thought to be one of these big kind of individual differences predictors of whether people end up in conspiracy communities. And some of these conspiracy communities definitely have a defensive posture and an alienated posture, and it's sort of like we're fighting the good fight and so on. So that is part of the reason I think people might go and search out some sense of belonging. There's a lot of old research on cults and things like that as well, which is an even more extreme example of this. And a lot of that does have to do with feeling accepted within a community where you weren't before. So I do think it is part of the puzzle of why you can get such extreme outcomes. But it's not always necessary, I don't think, you take a lot of religious groups that have this same kind of community aspect to them. That's not necessarily born of alienation, but it can be, I think, yeah.
So I would like to ask a non-stupid question. It's not even a question. It's actually, this was bewildering for me to listen to you. And I was trying to figure out what was so bewildering. And amongst my science friends, many of whom are here, there is a clarity above who are the real experts.
Yeah.
Who do you listen to?
Yeah.
And that comes from a gazillion things, taste. There are people in this room who, if they were to tell me something, I would believe it till my death. And there are people who could not get me to ever remember what they think, let alone count on it. Yeah. And in the end, what you were calling overconfidence at the end is, there's a role for that. There's a role for stubbornness in actually moving things forward. And I think that the people who I admire the most, this is a question, I guess, are great listeners, and so they're part of a group. But then there's a moment, in the shower or somewhere, and over long periods of time, where they conclude that they actually understand something that's puzzled them for a long time. Mm-hmm. And I think those are breakthroughs, and sometimes they look like craziness, because people talk to God, so I don't do that.
Yeah.
But I do talk to myself, and I don't get confused that that's God. Don't get confused by that. So I couldn't tell during your talk what I myself think of the role of individuals as opposed to groups, and I wish you would help me.
Okay, that was a lot of different non-questions. I'm not sure where to start. I will start by saying that this feeling of understanding, this phenomenology, there's actually an interesting paper by Alison Gopnik that calls that an orgasm of the mind. That phenomenology is really interesting because I actually saw that on display big time at the Flat Earth Conference. And so it's not always an accurate gauge. Sometimes it's this idea of coherence, where all of a sudden it feels like the pieces fit together, and you go, aha, I got it. But sometimes those pieces are put together by some pseudo-scientific person on stage and put together for everybody. You go, oh, aha. And that creates this really strong sense of belief. So I do find that phenomenology really interesting. Now, in terms of the importance of individuals, okay, so you said a few things. One is, a lot of your science friends kind of have more of an awareness of what their expertise is and what's outside of their expertise. And I think that could be part and parcel of what we do, of always bumping up against stuff that we don't understand or don't know as well as we thought we do. So we're like doing the toilet experiment on a daily basis as scientists. And so maybe habitually we start to appreciate that. Also, I think I say this with a little hesitation. If you go in the business world, executives are supposed to be confident. And there's definitely a leadership style of, that's not my area of expertise. I'm going to get someone in who really knows that. But, Wall Street doesn't want to hear that. They want the CEO to know everything. And the ethos is a little different. in academia, although, there's plenty of bullshit in academia too, right, as we know. So there's a lot, sometimes feigned expertise in everything in academia. The ethos might be a little bit different across fields. And then I guess the last piece, if I'm putting your sets of questions together, is this idea of sometimes individuals are really important. And of course, everything I said isn't that individuals aren't important. In fact, it's all predicated on the idea that we all have our unique pieces of expertise. But when I talk about bees and stuff like that, I'm discounting more, I'm like overstating the point about groups. Individuals are still important. And I do think there is such a thing as intelligence and individual thinking that is what's, partially what sets us apart from other animals. But this ability to form into groups, that's something that no other animals can do, even remotely like what people can do. I mean, if you look at, there are animal species that are much better at mathematics than kids, at a certain age. And they can do some pretty impressive feats, actually, but they can't collaborate in a social way the way that young children can. I purposefully am kind of understating the individual piece and emphasizing and highlighting the community piece. I hope that goes some way to answering some of your questions, or non-questions.
Wonderful. Thank you so much.
Thank you so much.
I have some of the other questions.
Oh, good.